Hello and welcome to MATLAB for Control Systems video tutorial. In this tutorial we will learn how to work with the transfer functions in MATLAB. Transfer functions in MATLAB consist of polynomials. Polynomials are represented by row vectors containing polynomial coefficients in order of descending degree. For example, let's look at the following code. Polynomial s cubed plus 3s squared plus 4 is represented by p equals to 1, 3, 0, and 4. We can find the roots of this polynomial by using root command. We can also reassemble polynomial from its roots by using poly command. To multiply two polynomials we use conv command. To find value of the polynomial at a given value of variable, we use polyval command. Now let's see how we can create transfer functions in MATLAB. To do that we use tf command. Since transfer function consists of numerator and denominator, we have to define them as vector polynomials. For example, to create a transfer function 10 over s squared plus 2s plus 5, we type in the following code. To create transfer function 1 over s plus 1, we do pretty much the same thing. Now we can obtain some of our transfer functions by simply adding them. Now let's find poles and zeros of our new transfer function. To find poles, we use pole command, and to find zeros, yes, you guessed it, we use zero command. To plot poles and zeros, we can use bzmap command. From the plot, we can see that we have 3 poles and 2 zeros. You can also see their values and information about overshoot, damping ratio, and frequency by simply clicking on them. Let's learn how to connect transfer functions in series and parallel. Let's say we have a system transfer function 1 over 500 s squared and controller transfer function s plus 1 over s plus 2. Series connection is done by using series command. To connect parallel, we use a parallel command. Now let's take a look at a feedback. Let's do a unity feedback of our system transfer function connected in series with a controller transfer function. We use feedback command with a sys and 1 as arguments since it's a unity feedback. Note that since there is no third argument in our feedback function, MATLAB assumes that feedback is negative. To do positive feedback, we need to use +1 as the third argument. In order to compute closed-loop function with the controller feedback, we use the following line. Now let's graph step response of transfer function 5400 over 2s squared plus 2.5s plus 5402. We will plot this function on interval from 0 to 3 with increments of 0.01. Step response is calculated by step function, and note we have to calculate a response for every increment of t, so we have to have t as the second argument of our transfer function. We can use plot command to plot the step response. Let's also create a grid by using grid command and label x and y axis using xlabel, ylabel commands. This concludes our tutorial on the transfer functions.